let's find the area enclosed by x equals y squared and x is minus y squared plus 1. Okay, in this case, the easiest way to start solving this problem is we start by first drawing these simple functions. Okay, the first one is x is y squared. Okay, so this is x equals y squared, and the other one is minus y squared plus 1. So this is 1. So the other one is just minus y squared shifted 1 unit down. Okay, and therefore we have the area enclosed by these two curves. So we see here, this is our area. Okay, we don't want to integrate with respect to x because we have to write an expression for this part here. So we need to find an expression for this one, and this one, and we need to have 4 functions. We can do that, but that's a bit of work. Okay, so we need to find these 4 parts of the graphs to be able to integrate with respect to x. But here it's easy for us to integrate with respect to y. Okay, so here our right function is this one, 1 minus y squared. It's on top of y squared. All we need to do is to find these 2 points where we have to integrate. Okay, so to do so we have to solve the equation 1 minus y squared equals y, and when we do so we're gonna get y or 1 equal to y squared. This gives us that y is plus or minus square root of 2 over 2. Okay, so this is minus square root of 2 over 2, and this is square root of 2 over 2. Therefore, to integrate with respect to y is just the top function, or the right function is, so we integrate between minus square root of 2, square root of 2, and we have 1 minus y squared minus y squared dy. We could have also noticed that we can just integrate this first part here, okay, because the function here is even. Okay, but anyhow, so we can just do it here. So this integral is going to be twice the integral between 0 and the square root of 1 minus 2y squared dy. Okay, now using the rules of integrations, we can see that this one is given by y minus 2 over 3 y cubed between 0 and square root of 2. Okay, when we do the evaluation, we're going to have square root of 2 minus 2 over 3 square root of 2 over 2 here, and this square root of 2 over 2. Otherwise we're gonna get something different, because this is the y that we're the limits of integration. So minus square root of 2 over 2 and plus square root of 2 over 2, as we found here. So therefore we have the square root of 2 over 2 minus 2 over 8 times 2 square root of 2 over 2. Okay, and therefore we can simplify. We're gonna get square root of 2 over 2 minus, let's see how we can, square root of 2 over 6. Okay, and if we multiply by 3 here, we're gonna get 2 square root of 2 over 6, which is gonna give us 2 square root of 2 over 3. If we can simplify this expression. Okay, so one more time here. So we simplify by these 2, we're gonna get 2 square root of 2 over 6, and multiply by 3 here, we're gonna have 2 square root of 2 over 6, and therefore this is our result here. we can do more than that. Okay, we can sometimes we can check that result with the calculator. Okay, and if we do so, okay, we're gonna get sometimes we just have to write it again. Okay, so here and I think that's it. I think we did simplify all we need to make sure that we get okay, I think I missed one 2 here. I missed a 2. That's why I think I get something here. 2 square root of 2 over 2 minus square root of 2 over 6. Multiplying by 3 would give us 2. Yes, I needed 8 and these 2 here. So I missed these 2 here. That's why I get something. So here I need to multiply by 2. I get 2 square root of 2 over 3. And let me see if I see the calculator. And I get that one is close to 0.940.942. So this is the area. Okay, we just want to make sure that we get it right, because when we do the computation we are trying to hurry up and we make mistakes. So this is the area here. Okay, we could have done this one in a different manner, so that's what I'm focusing on. So here we can write this part as a function of x, and this one as a function of x, and this one as a function of x, and this one as a function of x. Okay, we can solve here. Okay, here we can get that x or y is going to be plus or minus square root of x. Okay, the first part here is this one is going to be the square root of x. This one is going to be minus square root of x. On this part here, we're going to have that if we, let me just, so it's x minus 1 is minus y squared. We're going to have 1 minus x is y squared. So here y is going to be plus or minus 1 square root of 1 minus x. So this is the one here. Okay, and the plus 1 is here. As we see here, we have 4 functions. Okay, and with the square root is gonna require a lot of work. It's not a lot of work, but it's if you don't know, it's good to work out this one. Okay, because we know these graphs now. Okay, so this one here in terms of x is the square root of 1 minus x. This is minus square root of 1 minus x. So we know this one, we know these points of intersection. Okay, for the x it's gonna be different. Okay, and we're gonna just integrate between 0 and 1. Okay, but also we're gonna have to have this one here, these 2 points. Okay, so we integrate here between these points. We need to find these points to be able to integrate with respect to x. This one will require some work. Okay, and it's a good problem if you want to work it out. Okay, and we have all the tools and all the ideas that we can. So everything is clear now. So integrate between 0 1 but 0 and 1, but basically we stop here. Okay, we integrate here and we need to find this point, this one here. So to find this one here, we need to solve the square root of x is equal to square root of 1 minus x, and we can use symmetry to find this point, or we can solve minus square root of x is minus square root of 1 minus x. Okay, but it's a good problem if you want to solve with respect to x, but with respect to y it's clear. Okay, and I had to do this one twice to make sure that I get the right area. If we do it with respect to the x, we're gonna get this one here. Okay, I have done it myself. I tried to do this once, yes, and I see that it's gonna be a bit of work, but it's good to remember and review what you know before. So here we have all the details that we need. If you have any questions, comments, please let me know.